good evening, as I already said. Yes, as the chair introduced me, I'm Luca Bungaro, a PhD researcher at the University of Bologna, and today we talk to you about the work that I did jointly with Professor Mariagiulia Matteucci and Stefania Mignani from the University of Bologna and Dr. Marta Desimoni from INVALSI. The main object, the aim of this work was to analyze any dataset that INVALSI kindly gives to us, and in particular the object where the goals were double, and the first was to use what we strongly believe is a very important source of auxiliary information, that is the response time, in order to improve the estimate of the ability of students, but also to estimate another latent trait, that is the speed of the students during all the tests. And the second goal was to understand how and how much the characteristic of the students can influence both the response pattern, but also the response time during the test. And to that we used two models. For the first goal, the fully Bayesian approach model, and for the second, bivariate multi-error model. And I will talk, of course, of these two models more deeply, but first I will introduce you to the data that we used, that INVALSI gave to us, that belong from the 2018 mathematics data for grade 10. We use the INVALSI national sample of size 41,000 units, around 41,000 units, and INVALSI, to do the test, developed 12 different forms of 35 items each, and they tried to do the forms in order to be equal in terms of psychometric characteristic and, of course, for content balancing. And the data that we had contains all the psychometric characteristics, the rush characteristic for the rush parameters for all the 143 items, and also we have all the data containing the response pattern of all the students, of course the students in an anonymous form, but also the response time for each items, and also the characteristic of each student. That were not only socio-demographic, but we had other characteristics in which we are interested to know the impact on response and response time. For example, we have an estimate of the level of anxiety for the math test. So, for the first goal, as I said, we want to estimate not only the ability of the students, but also the speed. And we decided to use this approach, the fully Bayesian approach that is developed by, is proposed by Fox and Marianti, and that is has a hierarchical structure and is a conjoint model. So we'll estimate jointly the ability and the speed. And it has a hierarchical structure because it is divided in two levels. In the first level, we hypothesize that the models for ability and response time are independent and separate. So for the first model, for the ability, we hypothesize a normal ogive model where the probability of a correct response on an item K for student E depends by the ability of the students, theta E, but also by the difficulty, the rush parameter of the item K. As for the response time, the we hypothesize, as Van der Linden said, the log normal distribution for the response time. So the RTIK is the log normal of the response time, and this has this equation, so it directly depends, as we can see, by three parameters, where lambda k, the first parameters, represent the so-called time intensity of the item, and it indicates how much the item is time consuming, so how much time do you need to respond correctly to the time. Then we have phi k, that is the time discrimination parameter of the item, and he indicates how much the item is good enough to discriminate between different speed levels. So, for example, students with high speed level or students with low speed level. And then we have the zeta e, that is the parameter of the speed. So this is the latent rate that we want to estimate as for the ability theta e, and of course it is behind and explain the response time of the students. And then we have the error component, that is epsilon, that is distributed as a normal distribution. So this is the first level. We hypothesized that the models were independent, and in the second level we take into account the correlation between these two models, and so we have to hypothesize a distribution for the parameters that are the person parameters, but also the other parameters. And for both, we hypothesize a multivariate normal distribution, of course, because the person parameters are two. In this case, we have ability and speed. We have a bivariate normal distribution where sigma is the correlation matrix of ability speed, and the same is for the other parameters. We have a multivariate normal distribution. As for the bivariate multilevel model, sorry, after we estimated these two estimates, the ability and the speed, two parameters, we decided to understand how much the characteristic, as I told, influence these two parameters. So we decided to use a multi-level model that, very short and very fast, is a model that hypothesizes that the parameters can have a variation at multiple levels, and of course it's bivariate because we are considering two dependent variables, the speed and the ability. And at level 1 units we considered these two parameters. Hence, as level 2 units, we take into account the individual students, and then we decide to stop at level 3 units classes. So we decide to not go too further on a high rank, and so we have to take, we have to remember that the error component of this model will take into account all the effect of all the higher ranks units. For example, the schools that we are not considering because we are stopping at classes inside the schools. And to implement this model, first of all, we have to start from a base model, the so-called empty model, that we have to, of course, we have a model that takes into account all the two variables, because it's a bivariate multi-level model, as I told. And as we can see, it remembers a lot of a linear regression, where beta is a sort of intercept, is an intercept, is called the fixed part, and then we have v and mu that represent the random part. Then, starting from this empty model, we can start to add some the covariates that we are interested in, and we decide to have multiple, to test multiple models, sorry, and the models that we are considering are more complexes every time. So, for example, we have the model M1 in which we consider these covariates, for example, the fixed effect of student socio-demographic characteristic, but also the mathematical test density that I told you about, because we are really interested to test those covariates. And then we added other covariates on the more complex model. For example, in model M2, we find all the previous covariates, but also this new covariate, for example, the class average socio-economic status, but also the class average math test density. And the last model that we proposed also added the school track and the geographical area. So now we can start to see some of the results, the main results. There we have implemented the first model, fully Bayesian approach model, and so we obtain some estimates. These are the main index of the estimates for the parameters, for the item parameters and for the person parameters. But the most interesting thing is the distribution of the ability speed. In fact, when we plot the distribution, we can see that for the ability, we have a sort of normal distribution that agree with the literature. But for speed, we have a distribution that is really skewed, and to that end, it remains a lot of a log normal distribution, and in the literature it has to be a normal shape. So we really go deeply inside this, the reason why we have this shape, and we have some data cleaning, of course, and more deeply studies, and we found at the end that it not depends on the outlier, for example, as we will see further in this exposure, but we understand that this depends on the data that we have. This is the real shape of our data, and we hypothesize that this is because the probably a low engagement on the test. Because, for example, people that have a very high ability tend to spend more time on the items because they want to do well, and people that have low ability didn't engage much the test, and so give very fast answer and incorrect answer. And we will see again this result in the next slide. And then we also focus on the correlation about the item parameters and person parameters. As for the item parameters, we could see that there is a positive and significant correlation between the item difficulty and also the time intensity and time discrimination, and the other correlation are not significant. So we can say that the more difficult items are also the items that are more time consuming, but also that can be discriminate much between speed. And for the person parameters, we have one of the most interesting, of course, results, that is this strong and negative correlation, significant correlation between speed and ability. As I told you in the previous slide, this is because person who has a very high ability tend to be also the slowest one, and vice versa. At the end of the fully Bayesian approach, for the fully Bayesian approach results, we perform an extreme residual analysis. I will give you just the shots of the most important result. That is what I anticipated, that the outliers did not influence so much the distribution of speed and ability. As for the bivariate multi-level model, the first field that we focus about is the estimated interclass correlation coefficient. That, as we can see, it indicates that inside the classroom, for the ability, there is a correlation on the scores for the ability for the students in the same classroom, and the same is for the speed. And then we perform a likelihood ratio test on each models and also on the comparison of the models to see what is the performs best, and we decide to use the third one because it is the best, standing on the results. And so all the results that I plot here are about the third model, the more complex, and I focus my attention on some of the results. For example, we can see that for some of the covariance we can find that correlation that we have between speed and ability. For example, we can see that if we take the low prior achievement versus an average and high achievement. If you have a low prior achievement, you have, on average, the student have a lower ability, but a higher speed. And the same if a student is repeating one or more grades. And on the other hand, we have some variables that work differently. For example, if you are a first-generation immigrant, you have on average a lower speed, but also a lower ability. Otherwise, if you are, for example, the males are on average has a higher speed, but also a higher ability. And we also have some variables, some covariates, for example, the student socioeconomic status, that have an impact, a significant impact only on the speed, but not a significant impact on the ability. In conclusion, we can see that the ability and speed are inversely proportional, that item difficulty has a positive correlation with the time intensity and time discrimination, that the ability and speed scores of students of the same class are correlated, and also that student accuracy and time on test are differently related with student and class characteristics. And of course, what I believe is an important conclusion is that the response time, that is a an auxiliary information that is easily recovering when we do test on do a computer-based test as the INVALSI, has very potential to be taken in account, because we can perform more deeply and interesting estimate. And of course, the future developments are on improving the data cleaning, and we also found that the distribution that we have hypothesized is not fitting well the data, so we can try to consider an alternative distribution to the normal data, and also focus more deeply on the reason why there is the skewness, probably the low engagement, and so try to focus on that aspect. And to conclude, we also considered the speed as constant during all the tests, but we know that this is not every time true, so we can also try to consider a speed that can vary during the test for each student. Thank you very much. These are the references, and thank you for your attention.